Now let's talk about the logic of doing something asynchronously. In my case, first of all, this asynchronous can actually handle many things, especially the function of loading data from a specific file with this asynchronous. Now then, this asynchronous thing. When we say what is it, we usually have multiple lines of code when we execute a function. So as you execute this line by line, the function executes as a whole. But let's assume that in the middle there was some code that made a request. Then at the time of executing the code that makes this I/O request, the thread that is executing this function is put into what is commonly referred to as a blocking state. And only after this I/O work is finished, when this thread becomes lady state and becomes running state due to schedule rare. The lower part of the code that made this I/O request is executed. If I put it in a blocking state, when I execute a function, it is called sync. They usually work in sync. So what is a sync? This blocking doesn't happen, and we usually call it asynchronous. Alright then. If you explain it a little more, it's not in a blocking state. And then, at that point in my case, you said you would load some data for motivation B. Then, the thread that is responsible for loading this data is created the moment I execute some synchronized load code, and then this thread is created. I'm just about to start working. There will be this original thread running only to sync, but this thread doesn't wait for it to finish. He continues his work. In this way, when the thread I asked to load the data is finished, I implemented a function that the original thread that called this sync load catches this change and then stops what I'm doing for a moment and processes the loaded data. Yes, this is really a rough explanation of logic. Now, this is really another example of how it works in the game engine. If you give it to me, there will be a main root of the game engine. This is usually what we do with juice red. Then, while turning the wine gate, the wine water will circulate infinitely like this. Then, at a specific point in time, if you want to load data with non-consent, you can execute it, and a thread will be created. So what is this, for example, audio? Load data from a file to create an audio object. This function is done independently by this thread, and this original main thread just keeps going around the while gate and talking about itself. In other words, when I execute this sync load, this thread is neither blocked nor waiting. You just independently ask a thread to do what you and I told you to do, and then it does its job. And when it's done, it goes and catches it and handles it. So there are a couple of important concepts in implementing this asymmetry. The first is an object called this promise, and the second is an object called this ticket. We usually. Some meaning of this promise in future is that I made a certain three-way, do something, and I was promised to do it. It implies that we will then go to the future and receive the result value and process it. Just think of it. So what are these two data blocks? There are some shared resources that both promise and future hold. You're referring to the same object. And this promise acts to set the value of this data block, and this future acts to fetch this value. So we're going to create this thread just when we're doing this asynchronous operation. And let this thread have this promise object. After that, this thread just finishes its work and sets the value of this data block through the promise object that this thread had. Meanwhile, isn't there an origin thread that created this thread and made it work? Now this guy is this. First, we get an object called future from promise. That's why he has it. And then you use this future to get the value from this block of data. In other words, from the perspective of this original 3D, you can operate like this. Now future has received a return, then you can check it through this future. What can you confirm? You can check whether this data is currently set or not. As we continue to calculate, if the settings are not set, there will be no meaningful value when this is opened. If there is no meaningful value, you can continue doing what you are doing. But now that this thread has finished its work and set the value exactly, it will continue to do so, but when I continued on the original thread, it has a meaningful value. That means, now that 3D has finished the work I ordered asynchronously, I said that I can now handle the work, and I will handle my own work using the result value set by him through this get. This is the basic logic. So, in my case, I created this function. Process A passes the function I want to execute as the sync argument. Create a thread internally to execute this function. Then make it a promise object. And then we set this promise object to have a threefold value at the end of this function. In other words, when the thread that does the job I handed over ends 2 days, it sets a value on this promise object. Meanwhile, through this promise object, we said earlier that we get the future value returned. So we get the future value back like this, and then we pass it back to the return value like this. This process async function, then this process async function itself, is probably called on the main cell. Then he will now receive the future price back. So, like I said, we're going to do the work above. Come on. In the final cleanup, the main executed process async and returned the future value. And then he continues to work. But in the middle, you can check whether the job is over or not through the future revelation. Meanwhile, this thread has made me do something now. So this thread does the job, and when the job is done, I set the value to promise. From then on, the operation will be based on this principle that the value can be checked through the grid from this main point of view. Yes, so far we've talked about how to do things asynchronously.